everybody. Today we're going to be counting atoms and balancing equations. So, hopefully you guys know how to count atoms. We're going to have some more practice today just to make sure. So, we got counting atoms. So, we saw this one already. Water has H2O. There's two H's and one O, which means there's two atoms of hydrogen and one atom of oxygen. So, the subscripts tell us how many there are, and the superscripts, which we'll see in a minute, tell us how many molecules they are, and the coefficient. So you'll see that in a second. So let's see. So let's do some balancing equations. So here we have an equation for water breaking up into hydrogen and oxygen, which we would do in lab, but we're not there. So I don't recommend doing it at home. So this is electrolysis. So we break water into its elements of hydrogen and oxygen. So let's count the elements on both sides. So we got H, there's two H's on this side, and there's two H's on this side. Oh, that's balanced. That's nice. There's one O over here. Uh-oh. And there's two O's over here. So the oxygens are not balanced. So what do? Can I put a little 2 over here as a coefficient? Can I do, as a subscript? No, because I can't change subscripts because now it's going to be, instead of H2O, would be H2O2, which is a completely different atom. Remember the joke about the cat? The guy went to the bar to get some H2O, and the other guy said, I want some H2O2, and he died. So, what do? Ooh, it's kind of messy here. So what we do is, in the PowerPoint, you'll see a little bit better because all these things are a little strange. We have two H's. So how do we fix that? Two O's. What we do is we put a a coefficient in the front to make two H's. So we have two H's in the front, and then that makes four H's on this side, which kind of messes up the other side. So we have to put a 2 in front of this H over here. So let's see, we got four H's on this side, four H's on this side. How many O's on this side? Two O's on this side, and two O's on this side. So it balances. Yay. So let's see. Let's look here so we can see a little bit better. Okay, that's a little bit better now. So we have a coefficient of 2 in the front and a coefficient of 2 in the front here. Now, of course, there's always the invisible one over here. So let's count the atoms again. So we have four H's, two O's, four H's, and two O's. So we have the same number on both sides. Yay, it's a balanced equation. So here we go. So here's the review. So to balance the equation, all you do is you add a coefficient in the front to make sure the numbers are the same on both sides, and you do not change the subscripts, the little numbers on the bottom. Okay, but you do have to pay attention to them because it tells you how many there are there. But Mr. G, what's this energy thing? Don't worry about it. Don't worry about it. But notice the bottom, never, never, never change the subscript. You can't make it O. It has to be O2 because O2 is a diatomic. Okay, let's do another one. There's some more practice so you get a feel for it without all those little funny letters there. Okay, so what I did is I set it up this way. Same thing, but instead of having it on both sides, I put the letter in the middle. So we have how many FEs on this side? 1. So there's one Fe, so you write a 1 over here. And how many FEs on this side? 1. So there's 1 over here. That's good. Then how many O's are over here? There's two O's on this side. How many O's on this side? Only 1. So let's see what our next slide. Oh, there it is. So we have, once again, one Fe on this side and one Fe on this side. The Fe's are balanced. That's good. There's two O's on this side and only one O on this side. Oh, no. What do? Can I put a little 2 here? No. Can't do subscripts. So we have to do a coefficient. So how do we fix that? Let's take a look. Let's put a 2 in front of the F. Put a 2 in front of this FE, so we balance the O's. So now we have 2 O's and 2 O's. So the O's are balanced. But wait a minute, we just put a 2 in front here, which we messed up to FE's. So now we have 2 FE's over here, and there was 1 over there on the other side. How do we fix that? Oh, we got to put a 2 in the front. I call this the ping pong method, because you sometimes have to go back and forth and back and forth and back and forth. And of course, when you're done with the balancing, it's always good to double check your counting. So let's double check our counting. We have 2 FE's on this side, yay, and 2 FE's on this side, yay. We have 1 O2 on this side, so there's 2 O's on this side, and the 2, remember the 2 multiplies out, so there's 2 O's on this side. So now there's 2 FE's on this side, 2 FE's on this side, 2 O2's on this, 2 O's on this side, and 2 O's on this side. But Mr. G, O2, no, just count the atoms. Got it? So now it is balanced. Okay, so let's see. So what does that mean when we have this balanced equation? Well, there's actually a 1 hiding over here, so let me fix that. So, well, I'll take it away. There's a 1 hiding there, okay? So what does that mean? It means it takes 2 atoms of Fe, 2, to react with 1, that invisible 1 there, 1 oxygen molecule, 1 O2, to create 2 FeOs, which are 2 molecules of the FeO. That is a balanced equation. Now, if we look at the numbers that are in front, the coefficients, the numbers in front, which are going to be very important, are ratio of 2, these are the numbers, 2, there's a 1 hiding here, so it's 1, and then there's a 2 over here. So the ratio here on the bottom is 2, 1, 2, which is going to be important in a little bit. So let's do some more balancing, and I'll give you some more practice on the worksheet. Okay, let's see. We got the Al plus oxygen makes Al2O3. We can't mess with the little subscripts here, so let's see. How many Als we got? We got 1 Al over here, and 2 Als on this side. Uh-oh, not balanced, so we know we got a problem here. We got 2 O's on this side and 3 O's on this side. Uh-oh, not balanced either. So let's go fixing by adding some coefficients. So let's add a 2 in front of the Al. So we've got a 2 in front of the Al, which makes 2 in front of this Al. So there's 2 Als, and Als are balanced. But oh, there's a 2 here and a 3 here. Oh no, what are we going to do? Well, there's a little trick, and I'm going to share the little trick with you. Doesn't always work, but here's a little trick. You remember where we had to do a little crissy-cross before? Well, guess what? We have to do a crissy-cross. So to crissy-cross, we take the 3, put it in the front. We take the 2, put it in the front. And what happens? Oh, goodness. The 3 in the front makes 6 O's, and the 2 in the front makes 6 O's. Isn't that crissy-cross thing handy? So there's 6 O's and 6 O's. Yay, we're back. Wait a minute. I put a 2 in the front here. That just messed up with my aluminums. So now I got 4 aluminums. Oh, no. 4 aluminums on this side and 2 aluminums on this side. What do I have to do? Can you guess? Can you guess? Can you guess? Change the coefficient. But Mr. G, I just put it there. I have to change it? Well, sometimes you do. That's why I call it the ping pong method. You got to go back and forth, back and forth, back and forth. So now we change this to a 4. So now we have 4 Als on this side and 4 Als on this side. So let's double check our balancing to make sure we did it all right. Always double check your answers. So from the scratch, 4 Als and 4 Als. Yay, Als are balanced. 6 O's, 6 O's. Yay, O's are balanced. So now they are all balanced. Yay, yay, yay. So what does that mean? That means 4 atoms of aluminum will react with 3 atoms or molecules of O2 to create 2 molecules of Al2O3. So the ratio of the numbers in the front, and there's no hiding number ones, there's a 4, a 3, and a 2. And those are the numbers that you guys write in the little boxes on the sheet that is coming up in a second. So I will show you how to do the sheet in a minute in the next movie.